Hello, everyone. I'm delighted to welcome you to the launch of the Interdisciplinary Circular Economy Centre for Mineral-Based Construction Materials, which is part of the launch week for the UKRI National Interdisciplinary Circular Economy Research Programme, the NICER programme. We're only 4 months in, and I'm already regretting that we didn't manage to come up with a shorter name and catchier acronym. So I think we're going to start saying Circular Economy Centre for Construction Minerals, with apologies to geologists everywhere for misuse of the term minerals. So I'm Julia Stegman, Professor of Environmental Engineering at UCL and PI and Director of the Circular Economy Centre for Construction Minerals. And I'd like to introduce the co-directors of the centre, who are Leon Black from the University of Leeds and Mohammed Osmani from the University of Loughborough, who will also be facilitating the Q&A for our speakers, and our project manager, Lisa Hanselman, who's been working hard to prepare the session for today. So you'll be learning more about our centre and its participants later in the session after 3 excellent talks that will set the scene from the perspective of academic, government, and industrial stakeholders. So first, some housekeeping points. So the session is being recorded, and if you don't want to be recorded, please keep your video off. If you wish to ask a question, please use the chat, or you can also raise your hand using the reaction button at the bottom of your screen. And we just learned that Alt-Y also works for that if you can't find that reaction button. And questions will be addressed whether they're in the chat or whether hand raising, they'll be addressed in the Q&A sessions. If you have any technical issues, please use the chat feature, and Paul Bottrell and Becky Holly from the event coordinators will be working in the background to support you. Next slide. So the agenda we have today is, first of all, a talk by Phil Purnell, who has some fascinating contextual information to share. And then Fergus Herdance from Bayes will be talking to us about aspects of policy and the Transforming Construction Challenge. And Katie Beardsworth will tell us about the Network Rail perspective on the circular economy before I go on and present more detail about our centre. So there'll be a Q&A session after each of the talks and at the end. So first, we're going to hear from Phil Purnell. Phil is Professor of Materials and Structures at the University of Leeds. He has a background in cement and concrete technology, but his research now investigates all aspects of infrastructure from materials to business models, sustainability and economics, with a particular emphasis on the circular economy. There'll be an opportunity for questions after his presentation, which will be facilitated by Leon Black. When we get to the Q&A, as I've said, we'll ask you to digitally raise your hand using the reaction button or Alt-Y, and we'll call on you to ask your question. And you can also ask questions on the chat. So now, over to you, Phil.
Hello, everyone, and thank you very much, Julia, for that introduction, and thank you also very much for using a pre-lockdown photo from when we could all still get proper haircuts. So between a rock and a hard place, the sustainable circular economy in concrete. This is largely what I'm going to cover today. So when we talk about mineral-based construction materials, it encompasses a wide range of construction materials, but concrete is the one that takes up the biggest space. But many of the things that I'm going to talk about will also apply to the other mineral-based construction materials. Okay. So what happened to concrete? So in the 40s and 50s, concrete was the wonder material. It was the thing that was going to enable Corbusier's cities in the sky. We were all going to be living in these beautiful minimalist apartments. And then somewhere between the 1940s and the 1970s and 80s, concrete became a trope for urban decay. So the relatively poor quality material that characterized much of our 60s and 70s infrastructure started to decay, and this has led to concrete getting this reputation as a poor quality, low quality urban material. and it's often used as filmmakers as a trope for urban decay. And of course, in the last few years, there's been a new stick to beat the concrete industry with, this idea that concrete is somehow an energy hungry and a carbon hungry material. And you can see the various statements that are made in the popular and technical press about concrete as a material. And I think before we go any further into this, we need to unpick some of those statements and see whether they actually hold any water. So some numbers, and apologies for maths at this time on a Monday morning. But if we actually look at all the stuff we make as a species, so last year, or rather in the last year for which numbers are available, we made somewhere in the region of 40 gigatons of products, and that includes pretty much everything you can think of. And in the process of producing these products, we released about 37 gigatons of carbon dioxide or its equivalent in other gases. And if we look at how that's split amongst the major construction materials, so I've included reinforced concrete, steel and timber here, we can see that over half of that material was actually concrete. Over half of everything we make as a species is actually concrete, and anything that we make on that scale is bound to have a large footprint. And then we can look at the equivalent numbers for steel and timber in the first column there. So if we then look at the amount of carbon dioxide that's emitted associated with each of those materials, so we can see that although we make 22 billion tons of reinforced concrete and about 1 billion tons of steel, they release almost exactly the same amount of carbon dioxide. So although we release a lot of carbon dioxide through the manufacture of concrete, we also release an awful lot of carbon dioxide through the manufacture of steel and timber. And if you actually normalize these figures, which is the graph on the right, according to the amount that's actually made, so you divide the amount of CO2 that's released by the amount of the material that's been made, then you can see on this basis, in actual fact, from a carbon intensity point of view, reinforced concrete is amongst the lowest carbon materials that we actually use as a species, and steel and timber are very, very much higher carbon materials. And of course, analyses like this you can expand to much more interesting materials. So if you're a beer drinker, then you're clearly environmentally friendly, and if you're a chocolate muncher, then you're clearly causing serious damage to the environment. Now, many among you would have instantly spotted the flaw in this kind of analysis, and it's that a kilogram or indeed a ton or a gigaton of concrete doesn't do the same job as a kilogram of steel or a kilogram of timber. So we have to find a way of actually looking at this in a more intelligent manner. And the way we look at these in more intelligent manners is to make sure that we invoke something called functional units. Now, a functional unit is simply something that reflects the actual function that that material performs, rather than just thinking about it per kilogram or per meter cubed or per year of production of those materials. And there are some quite complicated graphs on the right here, but all they are is to demonstrate is that it's considerably more complicated than this. And in actual fact, there are no such thing as green materials, and we must look very, very carefully at how we use all materials. In certain situations, for example, timber is clearly the lowest energy and lowest carbon material, and steel is not. And in other structural situations, there are situations where concrete is very clearly the lowest carbon material, and steel is compatible with either timber or other types of concrete. It's a very complex situation, and if we don't analyze at the product level, at the functional unit level, then any analyses that we do is likely to be at worst fallacious and at best vexatious. So it's very important that we analyze at the functional unit level. There are no such things as green materials. Simply by saying you're using timber instead of concrete, you are not necessarily being green. Nonetheless, we must confront the gross numbers. The manufacture of concrete accounts for something like 60% of our resource consumption, and it accounts for something in the region of 10% of our CO2 emissions. So regardless of what arguments we might make to say that we actually use concrete very efficiently, these big numbers remain. And part of the job of this centre will be for Julia and her team to come up with practical and pragmatic ways in which we can reduce both of these numbers, not just the one at the bottom. And so how does this tie in with the circular economy? Because there's often a conception that the circular economy is primarily to do with recycling, is not really to do with carbon. Well, that's not really the case. The carbon is very much tied into how we achieve a sustainable circular economy. So in the middle of the picture, we have business as usual. We take a bit of the earth, we grind it up in various ways and heat it up in various ways. And in doing that, we release an awful lot of CO2. And at the end of that process, we generally put all of that material into the bin. although we might call the bin landfill. And this process is hugely damaging. We talk about emissions from buildings, but the emissions from the materials used to make the buildings is of a similar order of magnitude. So it's important that we address it. So what options have we got to reduce this generation of waste and this depletion of resources in this production of CO2? Well, option one is to make greener materials, and much of what we concentrate on in certainly the concrete research industry is making greener low carbon cements. And we'll discuss ways in which this can be done. Option two is to recycle materials. And this, of course, is very popular for many other materials and can be very effective for many other materials, such as aluminium and steel. But it doesn't solve the problem because recycling itself is not energy free, and it doesn't address demand and consumption. And you very often see in these systems that you get considerable rebound effects. In the specific case of concrete and other mineral-based construction materials, recycling very often, from an order of magnitude point of view, uses exactly the same amount of energy as using virgin materials. So that's not necessarily an option. Option three is to reduce demand. If you just make less stuff, then you'll emit less CO2, you'll have less depletion, and you'll make less waste. So, reducing demand is an important thing for us to do as well. And we can do this in various ways, by refurbishment, longevity, optimization. But this also involves socio-economic and cultural changes, so this makes it difficult. So actually achieving a truly circular economy in mineral-based construction materials is going to require a combination of all these three things, where we minimize not just emissions, but also limit extraction to the point where we're limiting it to renewable levels. So the circular economy is in many respects a combination of these different aspects, 1, 2, and 3. So let's have a look at some of these in turn. So how do we go about less embodied carbon? Well, one way, of course, for many other materials is to use less energy. But one of the fascinating things about cement manufacture, and by extension concrete manufacture, is it's already very close to its theoretical limits. So they sort of do the enthalpy calculations for concrete cement manufacture from its raw materials, and you get down to about 2 gigajoules per ton. We're already very close to that. Because the process operates at such a scale, it's already been optimized very, very heavily. Of course, the other half, or just over half, of the CO2 from cement manufacture comes from decomposition of limestone. So can we look for materials that aren't carbonate bearing in order to make cements with different chemistries? Because we know that these cements exist. We know there are other calcium cements, calcium sulfate cements, calcium aluminate cements, and we know there are cements that we can base on magnesium. But when we look at the proven reserves for the base materials, so after limestone, the next biggest calcium mineral is gypsum, and the next biggest is fluorite. These are produced at scales orders of magnitude below what we actually need to maintain cement and concrete production. So while these are useful clubs to have in the bag, they are not the whole game. We're also very keen on adding things like PFA and GGBS. So we take other people's wastes where somebody else has already been made responsible for the carbon, and we mix this with our cement. And this basically dilutes our cement and very effectively reduces the carbon footprint of the cement and the concrete, and also adds technical benefits as well. But it's important for us to remember that the parent processes for pulverized fuel ash and GGBS are changing, and they're changing in ways that are actually reducing our ability to reuse PFA and GGBS in concrete. And we also need to be cognizant of the fact that these materials are only low carbon because of accounting factors. They're not low carbon inherently. It's just that we assign the carbon associated with their manufacture to their parent materials. And relatively small changes in that allocation could actually very quickly make PFA and GGBS effectively have as high embodied carbon as cement, or very close to it. And so this, again, is part of a solution, but not a whole solution. We can look at the concrete we make already. Leon and I did some work over a number of years to look at how the actual embodied carbon of concrete varies as you change the mix design, without the need for special cements or the need for anything else. And you can actually optimize your concrete mix quite carefully to get quite large reductions in CO2 without any need for using new cements or replacement materials that can be difficult to get certification for. So thinking much more carefully about how we use the concrete that we specify at the moment can also give us quite considerable savings, which we can combine with the savings that we've spoken about before. Another thing that we can do, of course, is to simply use less concrete. So moving from option 1, if you like, to option 3 that we put on the earlier slide, how do we actually use less concrete? How do we reduce the demand for concrete? One of the things that we can do, of course, is we can look at the concrete sections that we actually build. So many of us on the call will be familiar with the process for instructing undergraduates how to make a reinforced concrete section. They take a loading situation from which they will gain a bending moment diagram, and they will look at the peak on that bending moment diagram, and they will design a section which resists that peak moment. And then we go about making a prismatic beam, a beam which is designed to resist the same moment all the way along the beam. And a very simple calculation will demonstrate that if you actually optimize the depth of that beam to match the bending moment along the beam, you can instantly save something like 20 or 30% of concrete. Put another way, 20 or 30% of the concrete in that beam isn't actually doing any work. It's just there because it's easier to make the beam that shape. And of course, we didn't always do this. So, this is not just a technical issue. This is actually an economic issue. If we go back to sort of the 19th century, the very early 19th century and the later 19th century, it was perfectly common for us to design the shapes of beams such that their shape reflected where the bending moment is in the beam. And so if you look at structures from this period, you very often see these hog's back beams, as they're sometimes called. Why don't we do this now? It's because of the change in the ratio between the cost of skilled labor and the cost of materials. In the 1830s, to pay the equivalent of a relatively newly graduated engineer would cost you about 8 tons of steel a year. To do that nowadays would cost you about 200 tons of steel a year in order to match their wages. And what this means is that the price of materials nowadays does not reflect the full cost of their production. So more efficient mining and processing, rather than leading us to use less material, has actually led us to use more material, which is a classic rebound effect. Another thing we can do is we can look more carefully at how we actually reuse buildings themselves. So rather than constantly moving to new build, constantly looking to demolish and rebuild, let's look to what happens if we actually refurbish existing buildings. There's a big push for us to move towards so-called zero carbon buildings, and these generally involve knocking down what's already there and building a very heavily insulated, very carefully ventilated building. But although doing that will obviously save you on your operational carbon, it'll save you on heating and air conditioning and lighting, it will incur a cost in the new materials that you have to mine out of the ground in order to make that zero carbon building. And when you actually look at the total carbon that's emitted over the lifetime of those buildings, then the picture doesn't change very much. And in actual fact, the jury is largely still out on whether it's more carbon efficient to refurbish existing buildings, thereby saving on embodied carbon and losing a bit on operational carbon, or to build new buildings where the converse is true. And so in the absence of any other information, because we can't make a simple heuristic decision as to whether a new build or a refurb is more carbon efficient, then as someone said before me, the greenest building is the one that already exists. And we should be looking at pushing our materials towards those which are amenable to helping us refurbish our existing built environment, rather than digging new materials out of the ground and emitting more carbon in order to build a new built environment. And durability and maintenance are therefore the key enablers for a circular economy. So building new buildings is sexy, but it costs you a lot of carbon. Understanding how to do durability and maintenance is going to be a key plank in moving towards a circular economy. It's silly season at the BBC, so this comes around sort of once every 4 or 5 years. So many of you will have seen this report over the last few years, and they always illustrate it with this idea that somehow the Romans had a magic formula for concrete, which if only we could rediscover in some sort of fantasy novel narrative arc, then we could make buildings that last forever. And I think people should be alerted to the classic case of the US Naval Air Force reinforcing their planes and being told about survival bias. We don't need to invoke magical materials. we have had and have had for many years, this is a graph from 1998, the design procedures, the technology, the knowledge of the material science and the chemistry to actually make sure that reinforced concrete buildings that we specify nowadays are perfectly capable of lasting 200-300 years if they're properly maintained and properly designed. And one of the things that we also perhaps need to move towards, because of course there will be times when we need to demolish existing built environment to make new built environment, is looking at ways in which we can actually reuse the components that make up our buildings. Because the value of the materials that we use is not in their materiality, it's in the function they provide, their ability to resist axial load, their ability to resist bending moment. So understanding how we can reuse construction components, not just crush up and recycle construction materials, is, I think, going to be essential to moving towards a truly circular economy in the built environment. And of course, for concrete, particularly cast in situ concrete, this is an Achilles heel because it's very difficult to dismantle and it's very difficult to understand what the properties of the sections are. I can tell you the properties of a steel I-beam with a tape measure and a textbook, but it's much more difficult to do that with a reinforced concrete beam where the steel is embedded in the concrete in ways that was very difficult for us to analyze it. And so in actual fact, the value in those reinforced concrete beams then switches towards, well, what's the information that we hold about these components, and how can we therefore add value to these components by understanding what's their residual capacity and understanding that we could therefore recover some of that high level value, that structural value, instead of it crushing it into aggregate to recover some of that relatively low material value. So that's a whistle-stop tour among sort of some of the high level stuff that Julia asked me to address. And the short answer here really is all of these things are equally valid. There is no silver bullet to moving towards a truly sustainable and circular built environment. But by looking at ways in which we can combine all of these different approaches in a sort of British Cycling Federation approach where we make multiple incremental improvements, but also looking at how we can push the agenda much strongly towards reuse and refurb rather than recycle. These are the ways in which we'll move to something approaching a sustainable circular economy for construction. If you'd like to read some more about some of the principles behind some of the circular economy work that we do, then the link is on the screen there to our recent paper on the principles of a circular economy. And so hopefully that's something that you can pick up some of the higher level principles. I suspect that's probably enough from me. So I'll just thank Julia and the team once again, and I'm happy to ask any questions.
So thank you, Phil. So now there've been a few comments in the chat from people, mostly comments, but a couple of questions. I'm just trying to go through them now, see what there is. There's a case. Thanks for do you think there is a case for bio-based aggregates?
That's an interesting one. I don't know is the short answer. There's always a case for these things. It's a question of whether we can actually make the case. My personal opinion is we probably have much better uses for many biomaterials. So those of you who are on the first launch this morning, there are a number of ways in which we can add value to bio-based materials by, for example, making textiles, biofuels, depending on whether you do or don't think they're higher value. And I think, as Leon and Julia know much better than I, some of the chemistry involved in making bio-based aggregates compatible with the very highly alkaline environment within concrete probably means it's not the best use of biomaterials. Having said that, for many years, people have used certainly biofibers, so things like jute and flax, very successfully in many countries to make sort of lightweight concrete sheets. So as with all these things, there's always a case, but it's very important to make the case based on a functional unit, not on a heuristic. So I hope that answers your question.
Okay, thank you. As has been put in the chat as well, if you've got any questions, either put it in the chat or also raise your hand. I'll see your hand being risen, and we can go that way. In the meantime, I've got another question for you. What do you think what do you think the major barriers are going to be to achieving circularity as regards to, we'll say, concrete use?
I think the major barriers are largely cultural.
Mhm.
You know, we have the technology to do this. It's not beyond the wit of the industry to, you know, specify low carbon concrete. It's not beyond the wit of the industry to make things in a precast way such that we could actually reuse the components. The industry is perfectly capable of refurbishing buildings. So we need to examine, as well as the technical aspects, we need to examine the cultural aspects associated with reuse, refurbishment, to make sure that we are choosing that, genuinely choosing that, where it can possibly be done, and not just knocking down and rebuilding for the sake of it because we want somebody to cut the ribbon on a building in 10 years time.
Okay, thanks. I mean, I'll say this is anecdotally because I'm hearing it secondhand, but the government, I believe, are introducing guidelines that all government contracts have to use low carbon concrete within 3 years, I think it is. Leave it for another day as to how you define low carbon concrete. There's a question from Theo Hanine, who's raised his hand here. So,
yeah, hi Phil. It's just quick question about, so at the beginning of your slides, when you compared concrete to steel to chocolate, I just wanted to understand what the thinking behind. So what's the thinking behind comparing concrete to steel rather than comparing like the commodity cement instead to steel? Don't you think those graphs become a bit misleading when you put it in that way? Yeah, just wondered that because the concrete is a composite that can contain steel in itself as well. So yeah, that's my question.
Yeah, but the concrete in those graphs is reinforced concrete, so that the emissions involved in the steel are included in that analysis. So there's a couple of papers which we can send you links to where you can look at that Leon and I put together. There's a suite of papers. So that very much includes concrete. The reason I compare concrete to steel is because we don't make buildings out of cement, we make them out of concrete. So that's why I do it. But even if you did that comparison with cement, you'd find that cement is a considerably lower carbon material than many steels. But the point is, of course, it's about the function that these provide, which is why in the second set of graphs, where we look at how the embodied carbon per unit of structural performance, how that changes as you change the size of the components that you're actually working with. And the reason I do a comparison to chocolate is frankly just to make a cheap gag.
I suppose I'll go out of turn from the questions because somebody has said, why does chocolate produce more emissions than cement and steel? I'll resist the urge to say it's lifetime. It doesn't last very long when I'm around. I'm guessing it's just the dairy content. Milk is incredibly carbon intensive.
Yeah, and you've got a lot of very high carbon processes. You've got to heat it up, you've got to cool it down, you've got to use a lot of water, you've got to grow the cocoa beans. You know, there's an awful lot of very high energy processes. But of course, that's on a per kilogram basis. We don't make anywhere near as much chocolate as we do concrete. And the point to be making is over half of everything we make as a species is concrete. So it's unsurprising that the emissions associated with concrete are relatively high. What is surprising is the emissions associated with making half of our material are around about 10% of our total emissions. And the point I'm always trying to make is not that concrete is any better or worse than anything else, but you need to look at the full picture. You need to look at it at the structural level in order to get a proper picture. And saying things like we're using steel is recyclable, therefore we're green is a very dangerous statement to make.
I'm aware that time's running out, but I've got there's two questions on a similar topic. So if I combine those into one. Also, partly I can answer some of the other questions as well myself in the chat later, but with an eye on the time. So what do you think digitalization and digital solutions, how can they support the development of more sustainable concrete?
Well, I think they're essential. I mean, I think if we're going to move to a situation where we're going to be, for example, reusing concrete components, as I said, you take a steel I-beam, you can work out its properties with the tape measure. You can't do that with a concrete beam. So it's going to be essential that we have some sort of database linked to items which are somehow embedded in the concrete, perhaps RFID tags, which actually make sure that we know what the properties of that concrete beam are, and not just what's the concrete mix, where's the steel, how much steel is in there, what's the grade of the steel, but also, well, how has this component been used before? How has it been loaded? Has it ever been overloaded? What environmental conditions has it been exposed to? So all of those are information. All the sensors and things that we need, we got all those. It's not a problem. It's an information problem. If we're going to be reusing components or indeed buildings, one of the key things we need is the information on what's the residual capacity of those buildings and components, and we're going to need digital solutions for that.
Okay, so thank you. Now, like I say, I'm aware we're running short of time for this presentation. So if we bring it to a close now, I'm not quite sure how we do rounds of applause like this, but I'll applaud on behalf of everybody else. So thank you, Phil, for your time. Pass over now to
me.
To you. Yes. Okay.
Thanks, Phil, and thanks, Leon.
Okay.
I think I am given to understand that our next speaker, Fergus Herdance, has been delayed. In having the pre-discussion with him, I learned that he's on urgent government business, observing new JCBs that use hydrogen power at an R&D centre in the depths of Staffordshire somewhere. So I suppose that's a good excuse for his delay, and hopefully he'll still be able to join us. So we'll go on and hear from Katie Beardsworth next. So Katie is Environmental Strategy Manager at Network Rail. She's responsible for overall environmental management and compliance, and after the publication of their environmental sustainability strategy in 2020, she's also leading on circular economy strategy for them. So again, there'll be an opportunity for questions after her presentation, which will be facilitated by Mohammed Osmani. And when we get to the Q&A, you can raise your hand digitally and we'll call on you to ask your questions, but you can also ask them during the chat. So over to you now, Katie.
Thank you very much, and thank you for the introduction. So I was invited here today by Julia to give a bit of a view from an industrial perspective, specifically in my case, rail, as to some of the circular economy challenges that we are facing, some of our ambitions, and I'm also going to cover some of the opportunities that we see, particularly with this research centre. So as Julie mentioned, last year we published our environmental sustainability strategy, which is a 30-year vision to serve the nation with the cleanest, greenest form of mass transport. And through the production of that strategy, we identified 4 key pillars that we were going to prioritise. So one of these is minimal waste and sustainable use of materials, which we kind of now in shorthand call our circular economy pillar. I'm aware it covers much more than minimal waste and sustainable use of materials, but that kind of summed up a little bit better for the rest of our business. So we've got a low emission railway, which obviously has a lot of overlap with circular economy, railway resilient to climate change and improved biodiversity in plants and wildlife. But the yellow highlighted area is kind of my main remit and how we're going to embed circular economy. So by 2034, we want to have circular processes in place for all of our non-hazardous materials, and obviously construction materials and mineral-based products are going to be a key part of that. So some of our challenges around embedding circular economy. This slide you don't need to kind of read in great detail, but this is an overview of the current structure of Network Rail. It's quite complex. We have some national functions or national service areas that kind of cover the whole of the business, and I sit within one of those, a technical authority. So we have overall responsibility for policy, strategy, several other areas. Our business is devolved into regions. So these regions run the railway day to day on also their own autonomous businesses as well, with interfaces with the national services. And at each level within the business, we have an interface with supply chain. So trying to change anything or update or innovate involves a lot of cross-functional and working right across the business. And it's very, very difficult to kind of understand who you need to speak to, at what point you need to speak to them. So there's a lot of challenges internally making that work. Also, our business's understanding of circular economy. So probably even the wording we've ended up using in our strategy doesn't help awfully, but when you bring circular economy up generally within the business to people outside of sustainability, you either get a blank look or they say, oh yeah, you've got to recycle more. And obviously this is one area of circular economy, but ideally the last thing we should be doing once we've done all the other steps and identified all the other areas. So I think we've got quite a big internal education piece to do to help our business understand what circular economy is, what it means for them, and what opportunities they have within their roles to kind of start embedding these principles. And a big challenge, possibly our biggest challenge, are our safety specifications, standards and approvals process. So obviously building railways, we have materials we need to use and they have specifications, and to change anything within this is quite a formal process you need to go to for most of the materials or processes we'd want to change. It's a slightly different process for civils engineering and structures, which has its own process, but for most kind of materials, which would include things like aggregates and rail and sleepers, we'd need to go through this quite detailed product approval process, which I'm not going to go into now, but each of those kind of rungs on the ladder there has its own set of procedures within it. So it's quite an involved process. Before you can even get to this though, for most products, you have to do something called a rail industry readiness level review, which again, don't worry about trying to understand the detail of this. It's more to give an oversight of the process itself. Like you can tell from this slide, the number of stages and the number of processes you need to go through to even get to the product approval stage. I think it needs to get to, on this chart, it would need to get to readiness level 6 or 7 before you can even go to product approval. So if we're identifying through our circular economy research, we should be using different materials or doing things in a different way, it's not going to be a simple case of, okay, business, let's just crack on and do it. There will be many hoops to jump through before we get there. And hot off the press last week, just to throw another kind of complication in the works, there was the William Shapps Plan for Rail was released. This is a rail review that was supposed to be published last year, but COVID kind of put it back, and I think it's had quite a few rewrites. But this basically sets out a vision to fundamentally change how the rail network works. In a few years' time, Network Rail will no longer exist. We will be brought under the umbrella of a new business called Great British Railways. And this will mean changes to probably everything that we do in the way we do things. So for the next few years, it will be relatively business as usual. This isn't going to happen overnight, but I don't know what kind of challenges we're going to face when trying to look at long-term changes or long-term innovations or research and development that we want to invest in when we know such big business change is coming. So it just gives another layer of complication. But having said all that, we also see a lot of opportunities and we have a lot of ambitions in this area. So our strategy is publicly available, and I can put a link in the chat as well. But this is our circular economy roadmap and the different stages that we're trying to achieve over the coming kind of years and decades, really. The rail is run in 5-year control periods. So we tend to kind of think in terms of control periods and what we can achieve by the end of each control period. So this one control period 6 right now, which ends in 2024. And as I said earlier, by 2024, we want to have tools and systems and processes in place for all to embed circular economy. So we've got quite a few things we need to do before we can get to that stage. We've got to map and prioritize our materials. We've got to do a lot of work with the systems and processes we currently have to update them. And I see a lot of opportunities with what this centre is trying to do in helping us along that journey. And so just for my last slide, I wanted to touch briefly on some of the projects that we're extremely keen on getting involved with. We've had various conversations so far with the project managers and people running these projects, because we see, if I'm honest, I see opportunities and possibilities with all the projects that this centre's running, and I think there's going to be some really great stuff coming out of it. But for these three in particular, so Project 1A and 3D, we're hoping to be industry partners for and really kind of embed that learning into our business. And with the eco-design of in infrastructure, with tunnels and bridges, we see a lot of overlap with what we're trying to do. So I think the centre itself is going to be a massive help to industry. And I think having industry partners is really key and a great way to do it, because it means that we're not going to end up with some academic research that's published and it's really nice, but it's really hard to translate into how we can use it in a business. It will be hopefully very much a collaboration approach, which means that we've kind of got the case study and the information there to move forward with it as a business. So I'm really excited about the opportunities and what we can do together with this centre. And thank you, that is me. So I'm happy to take any questions.
Right. Thank you very much, Katie. It's very interesting presentation looking at Network Rail and the circular economy roadmap. We're very delighted that Network Rail part of the center and working together specifically in the project that she mentioned. So I think again, same thing as in previous presentation. It's you have an opportunity now to ask Katie some questions. So please, again, digitally raise your hand if you would like to ask any questions, and then I can read it back to Katie. So for the moment, we don't have any questions, but I'm checking the screen. I've got a question for you, Katie. If we start looking at your circular economy roadmap,
sure,
and looking at the systems, because you said in 2020 you did this a mapping exercise in terms of identifying and prioritizing materials which could be targeted. So have you identified or a sort of a list initially of?
Sorry, no, that's something that's one of our early milestones. So that's something we're about to start doing. So we do have a research and development project that we've just had final approval for with funding, and we're engaging through our managed services framework to get someone on board to do that for us. So that project will initially be specifically looking at that mapping and prioritization work. So working with our contracts and procurement teams, understanding what are the materials and products we procure on a large basis or have the largest impact. There are some obvious candidates that are going to be up there, such as kind of steel for rail, timbers, sleepers, ballast. But we're hoping to identify some maybe not so obvious things that we also need to focus on. And that work will also give us at a high level, at least, a kind of a cradle to grave kind of map of what happens to that product at each stage of its life cycle at the moment, and help us identify where we can start to make better choices, or where we could start to think about how we improve things. Okay, so that's basically early days for the time being. We've got a few questions in the chat, Katie. First one, looking at from Anthony, saying how can the spoil from new rail lines, specifically in HS2, go to beyond that is landscaping, and is there a mineral reuse for it? Yeah, I mean, I would say that this is probably one of the things that this centre will be looking at an answer to, because I don't know the answer to that at the moment. Oh, sorry, in terms of spoil, there is some separate work through, I think it's a Chartered Institute of Ecological SAIM. It's looking at the reuse of spoil and how to do it in the most kind of biodiversity friendly way, and then different ways that we can be using spoil. So there are some kind of parallel pieces of like parallel work going on with different industries and different research areas. But at the moment, we're not great with spoil. It's not something we tend to reuse that well. Thank you, Katie, for that. Another question from Jamie Bartley, looking at how can industry assist with your plan project? I think it's, I mean, reaching out to me, I think as an initial option, if it's something you've come across and you think you can work with us on. I mean, as we get more mature, we will be getting closer to our kind of supply chain and other industry partners. So we have a couple of groups currently in operation, such as there's something called a Major Infrastructure Resource Optimization Group, MIROG, which works with a lot of construction and similar kind of industries. We have Rail Infrastructure Sustainability Forum that works with our supply chain. So we have various things that we work through at the moment, but if that's not things that you're currently tapped into and you identify opportunities, then feel free to reach out to me directly.
Thank you, Katia. Another question from Rebecca Hopper saying that she's aware of Network Rail, what they've been doing in terms of ballast cleaning, reuse, and then relaying some slippers. And then she was asking, has this changed?
No, the ballast cleaning, we still do that. We've got some high output machines that do some great work cleaning our ballast and kind of taking any spent ballast away. The reuse side, yes, it's reused through that process if it's cleaned on site, but a lot of the time our ballast is actually taken away, and as soon as it's off site, it won't get reused again. It will get cleaned up and crushed down into aggregates and resold that way. So it's kind of losing a lot of its value at the moment in that way. So there's not a lot of reuse of ballast. Relaying sleepers, yes, there's some small reuse of sleepers, but again, it's not widespread at the moment. It's not a kind of the first choice at the moment for how we do things. So it's about kind of making that more of a how we do business rather than a nice one-off.
Thank you for that. Another question from Peter Hopkinson. Looking at, the question is about the data on material costs and the potential value creation, looking at material cost savings, reduce carbon impact, and so forth. Basically, when you implement circular economy strategy.
Yeah, so not at the moment, Peter, no. That's one of the things that our research and development project, which due to start in the next month or two, is going to do with us or for us and help us with, is to get that kind of the value chain and the value creation across our key materials and products.
Thank you, Katie. I think there's a question on concrete foundation, I think for HS2 mainly. I think maybe it's related to the previous presentation. Maybe Phil or Leon can come back to you later on this answer for Mark's other question on concrete. Julia, how are you doing in terms of time? Are we going to the next presentation, or shall we carry on? No?
We can carry on for a minute. We're okay. Still, I guess Fergus is trying to join us, but is having some kind of network issue. So okay. If there are questions, we can go on. Or
yeah, I've got a couple of more questions for Katie.
Yeah.
Again, Katie, thank you very much indeed for your patience. A couple of more questions for me. Again, it's such an important document that Network has developed, the circular economy roadmap, which I'm sure a lot of companies are going to do the same, if not they have already done so. You looked at the 3 levels about the systems and the data and the engagement. In terms of data, any thoughts and ideas about the circularity matrix, particularly in terms of designing out waste?
Some thoughts. So one thing we don't want to do is create any kind of cottage industry for metrics, because if I'm honest, we have metrics and KPIs coming out of our ears at the moment, and I think the business is slightly fatigued with them. So the last thing we want to do is in a year's time come out and say, hey, we've got another 10 metrics for circular economy, you're welcome. I don't think they'd be too happy with us. So we're going to focus initially on what we're already doing to see what we can pull together to kind of give us a bit of a circular economy overall metrics. So we do have some data on kind of where we do host designing out waste workshops, which is something that our projects tend to do. There is some data captured on how much waste they would have created and how much waste they've designed out, but I'm not convinced we're very mature in capturing that data on a regular basis. So I think that's something we can definitely improve on, but should fit into the way that we're already doing things. I think we'd need to look at how we procure things and the kind of questions that go into our procurement strategies in terms of maybe filling out the circular economy picture. So the way that our centralized procurement works is we have category strategy managers who manage certain areas, such as one person might cover kind of rail and infrastructure. So we'd work with that person to say, okay, so when you're procuring rail, how can we make it more circular? What kind of questions do we need to ask? What kind of demands or requests do we need to make to suppliers to make sure we're being more circular with this? So they could be other ways that we kind of measure. Are we doing that? Or what kind of responses are we getting? Do 100% of our tenders go out with that information, and is it judged with enough weight in it for it to make a difference to the final submission?
Thank you. I think I'm aware of the time. Thank you so much, Katy, for that. I think a final question comes from Richard Tamblin, talking about to what extent does Network Rail have a clear mapping of the current waste which is produced and their composition. I think it's related to my initial questions, but here in terms of waste production and then the current waste which is produced and their composition, basically.
I would say we don't have a clear mapping. I would say a lot of the information is there, certainly for the waste it produces as part of our kind of maintenance and day-to-day activities. So we have 4 national contracts in place that cover all kind of our depots and maintenance waste, our offices, our stations, that we have a pretty decent waste breakdown for. What we've not really done is kind of gone through that waste breakdown and really kind of got into the detail of what's being disposed of. And we only send about 1 or 2% of our waste to landfill at this point. So we do want to kind of get rid of that last 1 or 2% and figure out what that is and how to kind of get zero waste to landfill. But the stuff that's going to recycling and the stuff that's potentially being sent to energy from waste, we don't have at the moment kind of a really clear, this is what it is, this is what we're going to do with it. That's on the list of things to do over the next year. Separately to that, what is slightly more difficult is our projects waste, because that's all done through our principal contractors and their subcontractors, and there is a process for them submitting that, but how the assurance of that and how accurately that's done every single time is still kind of up for debate. So that's another thing we're working on, is kind of getting that data clarity and making sure we're getting the right information.
Excellent. Thank you so much, Katy. I think Julia, I think should be okay to go to Fergus if he's around. Otherwise, we can keep.
I'm afraid he's not able. He hasn't so far been able to get through. So what we'll do is we'll go on, and I'll present the introduction to the centre. Sure. Thank you, Katy, for helping to set the scene, and Mohammed for your facilitation of the questions. And to Phil, who's sadly had to go on to another meeting, I think to do with the other centres that he's involved with. So yes, our centre is the Interdisciplinary Circular Economy Centre for Mineral-Based Construction Materials, and it's been awarded £4.5 million of funding from UKRI for the first 4 years of its operation. For the Leon and Mohammed are going to join me in doing part of the presentation, and we also have 22 additional world-class investigators from UCL, University of Leeds, University of Loughborough, Lancaster University, University of Sheffield, Imperial College, and the British Geological Survey, which you'll hear about more about in a few minutes. So the aims of the centre are to develop the scientific and socioeconomic understanding and technological basis for design and implementation of systems, processes, and policy that will support the transition to a sustainable circular economy. So just about everything that you can imagine in relation to built environment infrastructure, which includes roads, railways, harbours, ports, waterways, flood defences, airports, energy, water, and sewerage, etc., according to the ONS definition of infrastructure. And we've chosen this as a way of, I suppose, narrowing the scope, although much of what we do will also have more wider applicability across the built environment and indeed over the economy overall. But the UK is expecting to be making an investment of around 600 billion in infrastructure over the next 10 years. And government is supporting industry to make a huge investment in modernization of the industry, mainly for efficiency, which Fergus was going to tell us about. And we need to use the opportunity to also embed circularity alongside the 2050 net zero carbon target. And yeah, so we're going to be looking at mineral-based construction material case studies, which includes the construction materials themselves, so aggregate, cement, mortar, concrete, lime, block, brick, masonry, plasterboard, building and roofing stone, cladding, glass, and so on, and the associated natural mineral resources, so clay, limestone, dolomite, chalk, sandstone, igneous rock, brick, clay, gypsum, slate, sand, and gravel, and anthropogenic resources that can be used in industrial symbiosis, such as ashes, slags, and other mineral wastes, and excavated and dredged materials. And so one of our main aims, as is the case for all of the circular economy centers funded under this program, is that we want to develop actionable solutions for implementation within the lifetime of the center. So this shows the life cycle of construction minerals, or really construction materials overall. And you can see down the center we have the linear life cycle going from extraction of the resources to processing, manufacture, construction, or refurbishment prior to service, and then end of service leading to collection of materials. And in a circular economy, of course, all the materials coming out of those life cycle stages get circulated back at highest possible value. So in the diagram, the blue boxes are the life cycle stages, the green boxes are material stocks, green arrows are raw material flows, and the orange areas are byproduct flows. And you can see at the bottom here that materials can cross the system boundary in either direction for industrial symbiosis relating to other systems, other materials production and use systems. So our research is organized according to 3 challenges, where challenge 1 is looking at material stocks, flows, and impacts, which relates to the arrows and green boxes in the previous diagram, so the raw materials and the wastes. Challenge 2 is the blue boxes in the diagram, and it's looking at technical understanding and technical innovation for mineral-based construction material demand reduction, circularity, and impact reduction over the whole life cycle, so for all of the life cycle stages. And challenge 3 is about systemic enablers for circularity and addresses the whole system inside the brown dotted line in the diagram. So I'm going to tell you a bit more now about challenge 1, and then Leon and Mohammed will tell you about challenges 2 and 3. So the research questions for challenge 1 are, what are the material flows and stocks of importance? Where are they located? What are their quantities? And what are their characteristics that we need to know in order to be able to develop a circular economy with them? And what are their economic, social, and environmental impacts? And then also we need to know how these aspects change over time and in response to interventions that we might make, which could be technologies or policies or regulations or what have you, intended to try and stimulate a circular economy. And so we used these research questions to develop 5 focus areas. So each of the challenges, it has 5 focus areas. And in this case, the 1A is on the material flow analysis itself. 1B is about understanding data needs, both in relation to materials flow and in relation to stimulating use of materials and understanding their environmental and social impacts and economic impacts. And then 1C is about environmental impact and risk characterization. Looking at the aspects that we have to consider and how we understand the risks associated. And 1D is on life cycle assessment modeling, and 1E is on economic impact modeling more widely in the economy. So yeah, these blobs show the focus areas that I've just outlined, and the fact that they overlap with each other. They don't just overlap with each other, they also overlap with the research in the other challenges, and indeed the research that's going on in the other circular economy centers. The darker blobs are the 5 core research projects that are funded with the core UKRI funding. And up in the top left hand corner, we have a photo of Junyang Wang, who is our first postdoc working on material flow analysis for aggregates, so that one day when we're all able to meet in person, you'll be able to recognize him. So we have 5 focus areas for each challenge, each of which has a associated postdoctoral researcher, and leading to 15 2-year postdoctoral research projects that are being recruited in 2 years. So Junyang is part of the first cohort, and Mohammed and Leon will tell you about a bit more about their postdocs who've been recruited in the first cohort. So each postdoctoral researcher will develop a contribution to knowledge, so understanding a method or a technology, and implement that in a case study. So there are plenty of other topics that need to be addressed within the focus areas, also crossing over into other focus areas, and I've said also more widely in the circular economy, and the fly-in text just shows a few of those. But we're seeking that to, over time and well, over the 4 years of the center and beyond, to consider some of the other research challenges. So Leon, would you like to go on and introduce challenge 2?
Okay, so thank you, Julia. Yes, challenge 2, as says here, we're looking at technical solutions, technical understanding, and how we use this technical understanding to achieve circularity in the construction materials. Again, keeping with the idea that there are 5 research projects within this challenge, we've tried to span the entire lifespan of a piece of infrastructure, from design, so project 2A, through the materials that we use, then onto manufacturing and construction processes, in-life performance, service performance, and end of life, end of service. So we can consider this in terms of linking back to Phil Purnell's presentation. You know, we're looking at new materials and new construction processes to make the materials greener. We're looking at recycling materials, so that's the end of life, and how can we reuse the materials. We're looking at lengthening the lifespan of structures, so therefore reducing demand, all via design and build processes. So the 5 projects, say 2A, Shoma Kitayama, he's based in Leeds, looking at design of circular gypsum panels for facades, and how do you design the joints and the fixings that allow these, not so at end of life, you don't just come in with a wrecking ball and knock everything down, but to disassemble and reuse. Okay, so it's about modifying our design processes. 2B, we've got Theo Hanine, based at the University of Sheffield, looking at production of circular cement. So, you know, again, Phil mentioned in his presentation that we use a huge quantity of sources of calcium, so primarily limestone, for producing Portland cement. Can we start to use other raw materials, perhaps wastes or byproducts of other industries, to feed into cements to make new materials? Project 2C is going to be based at University of Loughborough, Loughborough University, looking at off-site manufacturing. So again, Phil's comment about the going from costing 8 tons of steel per year to 200 tons of steel equivalents for a experienced civil engineer. So can we change the construction process, move to off-site manufacturing or move to additive manufacturing to achieve circularity there? And the final two projects, both at the, again, back at the University of Leeds, looking at UK resource efficient concrete for whole life performance. So again, it's about trying to find alternatives to fly ash and GGBS that is currently used within Portland cement, but maybe, waste materials and byproducts from other industries that can be fed into or be used in concrete to improve performance, and that can include well, various things there. And then finally, the last project, again, this is due to start later this year, hopefully, well, later this summer, about maximizing circularity of concrete from demolition waste. It's like at the end of life, you demolish your concrete structure. How do we, reuse all those various materials? The coarse aggregate can go back into concrete, but the fine aggregate, does it go into concrete? Does it just get landfilled? Can it go back into a cement kiln? And it's about understanding the various drivers there. So technically, we can reuse all of the components within concrete, or all of the components of crushed concrete, again in fresh concrete, but there are often barriers, and some of those barriers are technical, and some of them are systemic barriers, which is a nice segue into Mohammed's section on challenge 3. Okay.
Thank you, Leon. So moving on from challenge 1 and 2, the aim of challenge 3 is to accelerate the transition to a circular economy in mineral construction materials sector through the development of a framework for proposing changes at 2 levels. The first level is to changes to business practices by removing barriers and creating market support. And the second change level is changes to policy and regulation to support the circular economy business practices. And challenge 3, it's the same thing with challenge 1 and 2, like Julia and Leona said. We have 5 research areas per challenge, and then for challenge 3, we're starting with circular economy business models. They're looking at eco-design, decision-making in terms of specification of materials, accounting and finance, and finally, standard policy and regulations. For like the 2-level changes of challenge 3 is reflected in the structure and content of the 5 project, PDRA projects. So we have the PDRA project A, B, C, and D. They're all addressing the changes to the practice of businesses, and challenge to policy and regulation will be addressed in project 3D. So let's look first at the changes to the practice of businesses, A to D. So the center and the core project will be moving from business as usual business model into a circular economy business model, which is the center. And the aim of that project is to identify opportunities, barriers, key circularity indicators that will inform the creation of circular economy business models for mineral construction materials. And the start of that project will be summer 2022. Then from that, 3B is looking at developing criteria for the characterization of mineral construction materials and validate this through these criteria in case studies. And then Evie Malula is the PDI for that, who started a few weeks ago working on the project. So moving from 3B into 3C, it's mainly in relation to the behavior change. So the aim of 3C is to identify factors affecting decision-making behavior for product specifiers and material specifiers, and influencing these through a value-driven digital information system, which will be developed in this project. And the start of this project will be summer 2022. And then moving to project 3D, the aim is to understand the key metrics which are used for internal and external investment decision, and propose an accounting and sustainability hybrid tool for the circularity of mineral construction materials. And then this project, for the PDRA of this project, is Longshan Zhou, who as well is based at Loughborough, started back in February. And then finally, the 3E the project is to identify new policy approaches and instruments to promote mineral construction material circularity, and to support, like I said, the 4 other projects. And PDRA 3E is Thea Linowska. Again, she's based at UCL and started a few weeks ago. In terms of relationship between Challenge 3 and Challenge 1 and 2, the identified opportunities for systems change in Challenge 3 will feed to the scenario modeling of Challenge 1, and the identified opportunity for technological innovation will feed back to the technical understanding of each life cycle stage of mineral construction materials in Challenge 2. Back to you, Julia, for the rest of the presentation. Thank you.
Thanks, Leon and Mohammed. So what this slide shows is the interdisciplinary core academic team. So in recognition of the fact that the circular economy is really not a problem that or a system that can be engineered by a single discipline, the UKRI funding has been very clear that they're looking for interdisciplinary interactions, and we've involved a variety of disciplines that you can see listed in rainbow colors on the right-hand side of the slide, with the names of the investigators from the different universities across the top of the slide. And the squares show areas of interaction between the investigators for the different postdoctoral research projects. So you can see that we've taken the remit to work in an interdisciplinary way very seriously. I guess partly because we think it's obviously important to work in that way to solve some of the intractable cross-disciplinary issues associated with moving towards sustainability through better resource efficiency. We also have some associated researchers from around the UK and also international groups who are working in this area, and they'll be linking PhD students to the program of work that we're going to be doing. And this is a similar slide showing our industrial collaborators. So we have here we have 34 national companies and organizations, as well as global companies and small and medium-sized enterprises that represent all relevant sectors, who have agreed to support our centre research with a total contribution of more than £1.9 million. And each of our postdoctoral researchers will have a one-year placement with one of our external collaborators following their 2-year academic research project. And so again, the squares show the areas of interaction, and we've really been delighted with the uptake of this idea among industry and their willingness to participate across the different challenges and focus areas. So in summary, here's the structure of the center. We have the 3 challenges that we just described to you, associated with 25 co-investigators and 15 postdoctoral researchers supported by the core UKRI funding, with industrial placements funded by an industry. And there'll also be at least 20 PhD students to be funded by the universities with matched funding from industrial collaborators, as well as PhD students from the associated research centers or researchers, and MSc students from all of those different academic organizations. Then we have this stakeholder interest group, and we have an equality, diversity, and inclusion working group and a knowledge mobilization and exchange team who will interact with the wider landscape. And one of the really key aspects of our structure is this independent advisory board, where we'll get input from government and UKRI and the circular economy hub, who's coordinating the activities of the 5 circular economy centers that are part of this program. And so this shows how the independent advisory board is structured. The IAB is going to be chaired, or is being chaired, by Richard Plotchek from the Infrastructure and Projects Authority, and there will be representatives from UKRI, the Circular Economy Hub, the Industrial Strategy Challenge Fund, Transforming Construction Challenge, and across 16 cross-cutting themes that we've identified apply across all the challenges and focus areas. And we've divided these cross-cutting themes into goals, transition tools, and impacts, where goals are circular economy principles, sustainable development goals, and resilience. Transition tools are metrics, standards, education, behavior change, digital innovation, and industrial symbiosis. And impacts are virgin materials demand, greenhouse gas emissions and energy, natural capital, social impacts, business impacts, and policy impacts. And I think something that's, quite important to recognize is that the impacts are not limited only to greenhouse gas emissions, which are definitely one of the chief problems of our age and for future generations, but so are some of the other things, or all of these other things that are listed for our impacts. So I think what the last thing I'd really like to say is about the upcoming activities. So, oh, sorry, go back one. Yeah, so we have some upcoming activities. The hub has some flexible funding to do feasibility studies, and they'll be telling us more about that on Thursday, and I think it'll officially come out in June for an autumn deadline for smaller projects to build links between the centers. Then from our center, there'll be a call for PhD students and projects that we'll put out sometime in the summer. We're thinking probably for a January intake of students. And we have a workshop on new collaborations coming up in July, as well as the next center meeting in October. Overall, the program will be issuing a call to support interaction of the centers with small and medium-sized enterprises, which will have an autumn deadline, but we don't actually have the exact dates for that yet. So those are things to watch, and we'll obviously keep you informed about that. So I believe we now have Fergus online. So given that I think his time is limited, maybe what we'll do is go to Fergus's talk and then have a question and answer for everyone, for Fergus and the centre, and anything else that anybody wants to get off their chest and share after Fergus gives his presentation. So Fergus is Deputy Director for Construction in the Department for Business, Energy and Industrial Strategy. His current responsibilities include policies to help improve the performance of the construction sector, the department's contribution to the government's house building ambitions, and its relationship with the Construction Leadership Council. So as before, please do ask your questions in the chat or digitally raise your hand when we get to the Q&A session. So Fergus, over to you.
Hi, good afternoon, everyone. I hope that you can all hear me. Just also to say at this point that I'm afraid I'm on the phone rather than being able to join the meeting directly by Zoom. So I'll be talking through the slides, and hopefully I'll do so in a way that the people who are controlling the deck will be able to follow, so that you'll be able to see what I'm referring to at each point in the presentation. But if I just start with a quick run through of the significance of the construction industry to the UK economy. It accounts for around 9% of all GDP, or around £400 billion of that economic activity, and around 9% of employment, or 3.1 million jobs. So it's an enormously significant industry. It operates across the whole of the UK, and it contributes in a variety of different ways. You have the contracting part of it, that people who actually build stuff, where you have around about 2.3 million people working in the industry. But we also have very significant product manufacturing sectors, which accounts for about another 300,000 people in employment. And we also have a very vibrant, dynamic and internationally competitive professional services industry related to construction, which employs about 350,000 people. And the real importance of construction is as an economic multiplier. So if you invest in construction, you get a direct and indirect return on that investment. And most of the studies that have been undertaken estimate that if you put £1 into the construction industry, you generate close to £3 in return by way of economic activity. But the sector does have some weaknesses, and in particular, its intrinsic weakness is its poor productivity performance. Certainly compared to the whole economy, but certainly compared to some of the more productive sectors like manufacturing. And this is in part linked to its low level of investment in R&D, despite being considerably larger than sectors like aerospace and automotive. The construction industry on an annual basis invests about a fifth of what they do. And this is intrinsically linked to its relatively poor performance. And it's something that we need to try and address as we go forwards to improve its productivity, but also to improve its sustainability and reduce its carbon emissions. And the scale of the carbon challenge is significant. This is onto the third slide now, because the built environment accounts for around about 40% of UK emissions every year, or 350 million tonnes of metric tonnes of CO2. This is accounted for by a number of different things, around about, it's both the embodied carbon, which exists in the built environment, and the operational carbon that's linked to the operation of buildings and to the creation of new buildings, and also the way in which people use them. So you have about 22% of UK carbon is embodied carbon within the built environment. And there are some other very significant contributors to the level of carbon emissions from the industry. Around about 48 million metric tonnes comes from new construction related activities, of which over half relates to products. And these are typically the energy intensive products that the sector uses, so concrete, steel and glass. Whereas only about 20% of these emissions is actually linked to on-site activities. Although, because of the volume of construction products and materials get that get shifted around the UK in order to build things, actually around 10% of construction emissions come from transport and logistics. So by reducing the volume of products that are used and by using those more efficiently, recycling them close to where they're used, or finding ways of reusing buildings, you will have a significant impact on those emissions as well. Moving on to the next slide, the UK has government to set a pathway to net zero carbon by 2050, and we are well aware that the built environment is a key sector to this, and one of the sectors whose emissions we have to reduce dramatically. The trajectory, which is going to be incorporated into law, is for a 68% reduction on UK carbon emissions using the baseline of 1990 emissions of 68%. We will be aiming to get that up to 78% by 2035, and these are critical steps if we are to achieve net zero carbon by 2050, and also make the contribution that we need to make to holding climate change and to the increase in global temperatures to closer to 1.5 degrees Celsius than 2 degrees Celsius, which most experts think is what we should be trying to do. And in terms of what that implies for the industry and what the priorities need to be, we are following very closely the recommendations of the Climate Change Committee, who've identified a number of key areas, including decarbonising residential heating, reducing the energy consumption of buildings, decarbonisation of industry, and that's both manufacturing industry, but it's also things like construction plant, for example, by shift to electrification, or for larger equipment and industrial facilities, the use of hydrogen, and also through a significant reduction in vehicle emissions, so heavy goods vehicles, vans, and other forms of transport that the industry uses. Moving on to the next slide, reducing carbon emissions is also one of the objectives of the Construction Net Playbook, which overall aims to reset the relationship between the industry and government to make it a lot more strategic and less transactional. And what we really mean when we say more strategic is that we want the industry to focus on what it can contribute to the delivery of strategic policy objectives that the government has set. So that includes improving the productivity of the industry and making it more efficient and innovative. It also includes improving building and workplace safety following the Grenfell Tower fire. But very importantly, it also means making a contribution to delivering some of our environmental policy goals, including the transition to net zero carbon, but also other environmental objectives, so reducing particulate emissions or promoting biodiversity, and also delivering greater social value, so providing opportunities for training or long-term sustainable employment for people in disadvantaged groups or in less economically prosperous parts of the UK. And that includes through giving them access to jobs that are likely to be sustainable in the long term, which could include an area like construction, retrofitting, or other jobs linked to making the industry greener. Moving on to the next slide, one of the things that we have been investing over the last few years is something called the Transforming Construction Challenge, which is a £420 million public-private sector investment, which aims to improve the industry. So the strategic objectives are a 30% reduction in whole life costs, primarily through driving efficiencies and productivity gains. We also want to increase the speed of delivery of projects by about 50%. But more importantly, we want to reduce by 50% the carbon emissions at all stages in the life cycle of the building. So that's the embedded carbon that they incorporate, as well as the operational carbon that they emit. And we've invested in a number of projects, initiatives, and research infrastructure to contribute to that. We've put £70 million into the Construction Innovation Hub, which is developing digital and off-site manufacturing technologies. We've also invested £36 million in the Active Building Centre at Swansea University, which is developing technologies that generate and store energy and heat that you can incorporate into the fabric of a building. So in very crude terms, you're turning the building into a power station. And we've also been supporting a number of demonstration projects and a number of R&D and academic research projects. And these have included a number which are aiming to better understand the amount of carbon that's embodied in infrastructure and buildings and then generated during their operational life. But also to try and reduce the number of the quantity of materials that they use and improve the processes for creating buildings. And moving on to the next couple of slides, there are a number of projects that I just wanted to highlight as examples of what we're doing that are relevant to the work of the centre. So, for example, the Transpark academic research programme was looking at business model innovation in the parking sector and looking at how we can transform what are these often fairly monolithic concrete blocks in our city centres into hubs that can both generate and store electricity, but also act as at the heart of electric vehicle charging networks for cars, vans and the delivery vehicles, and also help to better integrate systems within the built environment. And this is very much inspired by the thought that actually to demolish and remove these buildings would have very significant carbon consequences. It would be much better if we could reinvent them and find ways of reusing them that enable them to contribute to a lower carbon future. The second project to highlight on this slide is automated digital processes for better improving production in factories. And this is quality, but it's also sustainability. So we're expecting this to improve productivity, but we're also expecting this to cut waste that's generated through industrial processes by around a quarter. And just moving on to the last couple of case studies that I wanted to show you. One of the other ones is that we've been developing as a smart digital platform to map the most efficient programme plan and help improve the productivity and operation of the construction supply chain. And we think that this will have a significant impact on cost, reducing timelines and improving overall productivity. And it will also have important sustainability benefits because you are maximising the efficiency of the supply chain. And then finally, and this is one of our flagship initiatives and it's being worked on by the Construction Innovation Hub, it's a product-based approach to design and construction where we take the model that's been developed in the automotive and aerospace industries of a product platform where you have a set of component parts with standardized interfaces and connectors that you can then manufacture. And by using this and applying it to building types like schools or certain types of accommodation or hospitals that we produce a lot of, we think that we can significantly reduce the amount of carbon that's both embedded in a building and which it generates through its operations, mainly by using less materials and designing and building a much higher quality, more energy efficient building. And this is also one of the ways in which we see the route to market for the energy generation storage technologies that are being delivered developed by the Active Building Centre, because we are actively designing things like a product platform for schools that will enable us to incorporate those technologies in it. So I will conclude there. Thank you for listening. Apologies that I was not able to join you via the Zoom call and you weren't able to see me. But hopefully I've given you a bit of an insight into the overall direction of travel for government policy, but also some of the issues and initiatives that we're actively working on at this point in time. Thank you again.
Thank you very much, Fergus. Oh, I'm just going to say, Lisa, you're going to take over for facilitating the Q&A for Ferguson for the centre presentation. Is that right? Yeah.
Yes, correct. Thank you, Julia. And thank you very much, Fergus, for taking the time to join us despite the few issues. This was a very interesting presentation. So I'd like to invite everyone once again to put their question into the chat or just to digitally raise your hand if you'd like to speak specifically and ask a question to either Julia, Mohammed, Leon, or Fergus. Maybe I'll just start with a question for Fergus that comes from Rebecca, which is, oh, sorry, I got confused, apologies. Fergus, a question from Anne actually. What are BEI's plans on increasing resource productivity as envisaged for example, in the industrial strategy announcing a regenerative circular economy?
Well, quite a lot of the programs that we invested in through the Industrial Strategy Challenge Fund or other ones which are supported by UKRI are aiming to improve resource efficiency and to support the development of a circular economy in the UK. I mean, the ones that I'm most familiar with are obviously the ones that we've been doing in the area of infrastructure and construction. But we have been, I think, over time, gradually shifting the emphasis of a lot of the work that we are doing towards what we can do to promote a circular economy, and look at things like how we can actually how we can reuse materials, how we can substitute materials that we use now, particularly things like concrete and steel, with more sustainable materials. And also, and this has been quite a big focus of work for us, and it's been something that the Construction Innovation Hub has been working on through the Centre for Digital Built Britain. It's how we can actually make buildings smart and digitise the construction supply chain so that we have an accurate record of all of the products and materials that have gone into buildings, what's happened to them when they've been in the buildings, and the stresses and other things that they've been subjected to. And so we have a comprehensive data set that enables us over the course of the life of the asset to work out what we need to improve, what we need to replace, what we need to repair. And if we come to dismantle the building, what we can recycle and what we can reuse so that we're not wasting materials through doing things inefficiently, either throwing away things that could be reused, or in case of things like steel, putting them through an extremely energy intensive process that might not actually be necessary because the steel bar or girth section could just be reused. So there is quite a lot going on at the moment, and my view is that certainly over the next spending review period, this is going to be something that we invest more in consistently, because it is absolutely critical to delivering net zero carbon by 2050.
Thank you. Thank you so much for this answer. We've got two follow-up questions on this, which are related to the industrial symbiosis. And first question is around whether the results of BEI studies will be published, and if so, when, and if they will be accessible to everyone.
As a rule of thumb, we publish pretty much everything that the department is involved in. I mean, so most of the studies and other work that we commission, we would, as a matter of course, publish that. A lot of the work that's done by UK Research and Innovation, again, we would publish that as a matter of course. So yes, I can't see any reason why we would not publish any research reports or other relevant information or statistics that we developed internally or through one of our projects.
Fantastic, that's great. Do you know approximately when we can expect that, or has that not really been discussed yet?
Oh, it's on an ongoing basis. This is simply a general policy. So as we produce things, as they get developed, we will we would be publishing them, and we usually publish them in a fairly timely manner.
Okay, thank you very much for this. I guess I've got another question in response to what has been the response of the platform approach and production platforms you've just been talking about from the different parts of the construction sector. So designers, contractors, clients, how they've all been reacting to this?
I I mean, very positively, as you would expect in a large and diverse industry. There are different views about the merits of this technology, and there are also different views about how it should be taken forwards. But this is something that we've been working on for about 4 years now through the Construction Innovation Hub. And we are already seeing some major clients in the public and private sectors. So, for example, DfE in the public sector, but also the Department for Health and the Ministry of Defence and the Ministry of Justice in relation to prisons are all looking at how they can use this approach to deliver the capital investment programs that they're responsible for. And then in the private sector, well, one of our demonstration projects that we've funded through the Transforming Construction Challenge is with Land Securities, who are using this approach to deliver a major commercial development on the South Bank in London called The Forge. It's at 105 Sumner Street. And we think that when this building is completed, it will be the first building, certainly a building of any scale, that has been produced using a platform-based methodology. And it's actually being constructed now. And as well as Land Securities as the client, you've got Mace and Sir Robert McAlpine as the managers for the project, who are actually responsible for coordinating the activity. And you've got a whole range of other subcontractors and consultants who are also involved in this. DfE are a little bit behind, but we are hoping that we will have a prototype of a school built using a product platform developed within the next year or two by the end of the Transforming Construction Challenge, which is due to end in 2022. So we will then hope that shortly after that, we would be in a position to start using these to deliver schools. So I think it is a technology that's increasingly starting to permeate the industry. And I know it's one that a large number of firms and clients are looking at. So our expectation is that this approach is going to form at least part of the future for the industry in terms of the way in which we deliver buildings and infrastructure.
Thank you, fantastic. Thank you so much, Fergus. I don't know if there are other specific questions for Fergus. If so, please raise your hand. Otherwise, I will ask a few questions to Julia, Leon, and Mohammed around the center. And maybe the first one that has come up is for Julia, maybe to answer about how academics, industry, and policymaker can get involved in the center in the next 3.5 years.
Thanks, Lisa. I think we're very keen to involve other academics and other industries, other companies in the center. So academics can be involved as associated researchers who will link their doctoral students with relevant projects to participate in the center activities on an ongoing basis. Industry can join our team of stakeholders and provide the same sorts of contributions that our existing collaborators do, which range from the one-year placements and doctoral studentships to things like data and access to equipment and so on. As I noted, there is this additional funding that's going to be available from the Circular Economy Program to support small and medium-sized enterprises. So we hope that some of those sorts of companies will work with us to apply for that and do things that are cross-cutting across some of the, either within our center or cross-cutting to the other centers. And there's also a flexible fund for these feasibility projects that is going to be announced by the hub as well. So we're going to be running our center meetings on a semi-annual basis, and those will really be people who have an established connection with the center. But staggered with those, there'll be semi-annual themed workshops that everyone interested in that particular theme can participate in. And I saw that there was a question in the chat about how to get in contact, and I think you've given people the center email, which there is also, I think the closing slide has that as well. So please just do get in contact if you're interested to collaborate with us, whether academic or industrial or something in between.
Yes, thank you. And absolutely, you can contact us by email. We're also on Twitter and we've been tweeting today, so you can follow us. And we'll be creating a newsletter for everyone to keep in touch with the centre's activities, and we'll share further information with you as soon as this is up and running. Leon, I think there's been a question around the focus of the challenge too, and why has it been this emphasis and focus on concrete and cement for challenge? Yeah,
so I suppose I should say it's not all cement and concrete. There are other projects as well, but the overwhelming focus is on cement and concrete, particularly within the technical challenge, or sorry, the challenge 2, the technical challenge. I think there's two reasons for that. And the first one is probably, as Phil made very clear early on, we use an awful lot of concrete. There's 4 billion tonnes of Portland cement is equivalent to at least 10 billion tonnes of concrete globally. And so finding means to make that greener, make that more circular, so we can encourage reuse, is a benefit. The other issue is, if we consider circularity being about maintaining maximum value, other materials, so gypsum plaster, can be recycled readily, and an awful lot of plasterboard is recycled. Steel can be recycled readily. Concrete can be recycled, or some of it can be recycled, but at present, well, the current figures show about 90% of it is reused or recycled. But this hides horrible downcycling. Number of instances where you hear from contractors that a building is demolished and the concrete rubble is used to improve drainage on site, is the stock phrase, which is a way of saying, well, you know, if the soil's a little bit heavy, a little bit waterlogged, we can mix some building rubble in with it and it improves drainage. What it actually does is it avoids paying the gate fee to landfill it. And so it's not being reused, it's just being buried and then built on top of. And so if we can find some way of maintaining this value, both financial and a carbon value, it's incredibly important. It shows great potential there. So that's the reason why it's focused on concrete.
Thank you, and I think that explains it really well. If you've got reactions to that, please put it in the chat. I think I'll just turn to Mohammed for another question, which is, there's going to be a lot of research developed and hopefully a few solutions proposed in the centre. So how do you plan to disseminate the findings and ensure uptake in the industry and through government?
Thank you, Lisa. Yes, I think we have got a dissemination strategy, academic and industrial as well. So definitely to be the conventional channels of publications, workshops, conferences, and so forth. And we will have some written documents, which could be guidance documents, which could be briefing documents, which will support as well the findings across all the 15 projects, plus the supporting PhD doctoral studies, as well as hopefully joint outputs across the 5 sectors as well, the 5 centers, sorry, the 5 UKRI centers. So it is part of our dissemination strategy that we're going to make sure that all our outputs and findings are properly disseminated. And it will be as well noted in the newsletters and as well through all the social media announcements as well.
Right, thank you very much. I think I've got one final question in the chat that maybe Julia, as the director, you might be better placed to answer. Well, I don't know, because it's about industry, but does industry have policy in place to look at protection for farmland for the long-term future, taking into balance the built future needs for transport and construction? And maybe this is where Katie can also jump in if she's still there.
Yes, I think that would be a good one for Katie to take. And I don't know if Fergus could also, I mean, it's a question for industry, but Fergus might have insights about it. So, yeah.
Yeah, sorry.
Do you want to repeat the question, maybe?
Yes, please.
Does industry have policy in place to look at protection for farmland in the long-term future, taking into balance the built future needs, transport and construction?
Farmland. It's not something I'm aware of, I'm sorry. It's kind of not really on my radar at the moment.
No problem. Fergus, if you're still there, do you have any information on this?
Apologies, could you just repeat the question quickly?
Absolutely. Does industry have policy in place to look at protection for farmland for the long-term future, taking into account the balance and the built future needs?
So was it a policy for which group was it, sorry?
For farmland. So it's a little bit outside of our scope, I think, but I think
for farmers.
Yes.
Was it? Yeah.
Farmland, farmland. I think it's about preserving land. Well, the balance between the built environment and farming.
Yeah. Okay. Yes, that makes the question easier to understand. Yes, I mean this is something that I think you're going to see increasingly reflected in government policy statements. So last month, government contributed to the development of the vision for the built environment, which set out a clear aspiration for how the built natural environments should complement each other, and how, when we are looking to make interventions in the built environment, we should do so in such a way that it complements and enhances, if possible, the natural environment. I think that's going to be a theme that's reflected very strongly in the forthcoming Infrastructure and Project Authority Transforming Infrastructure Procurement document, which will hopefully be coming out in the next month or so before the summer. And also, if you look at the direction of other government policies, and I'm not directly responsible for these because they are the responsibility of DEFRA, but we are increasingly moving towards a policy where we look to interventions in the built environment, not only to not compromise the environment, but to enhance things like biodiversity and potentially in future other environmental benefits as well. And if you look at some of the investments that have been made by projects like Crossrail, and accepting that that is a large and controversial project, but they have made a lot of investments to mitigate their environmental impact and, where possible, to enhance the environment. And I think that is going to be one of the models for the future. And certainly, given the importance of tackling climate change, I don't think this is a trend that's going to be reversed.
Great, thank you very much, Fergus. That's very helpful. So I think we kind of run through all the different questions that were raised today. Before we close the meeting, I'll hand over to Julia for a few closing words. And thank you again, Fergus, for joining us despite the few issues.
Thanks very much for having me.
Thanks, Lisa. I just wanted to point out, in case people missed in the chat, Jamie Bartley has put in a comment about a call for evidence on UK biomass production potential, which also relates to the farmland issue. So yes, so in closing, I guess in the chat, I think there's a slide that has our email address, but it's also in the chat, so please do take note. I hope you've all found the perspectives provided by Phil, Fergus, and Katie as valuable as I have. So both circular economy and construction are clearly dynamic areas where plenty of innovation can be expected in coming months, years, and decades. And it's my hope that the Circular Economy Centre for Construction Minerals will be a seed for some coherent activity that will grow and extend beyond the timeframe of the UKRI funding, with the participation of many others than those who are already involved. So please do contact us if you'd like to get involved. You can also keep in touch with our activities by following us on Twitter. I think there's something about a note about a participant survey that's on the platform that the CE Hub would like you to complete. And yeah, before closing entirely, I'd like to thank our speakers. So Phil Purnell, Katie Beardsworth, and Fergus Herdance, as well as Lisa Hanselman for her excellent organization of the event, and the CE Hub staff and Huva, and all of you for your attention. We look forward to further interaction with you. Hopefully it'll be in person next time.